We continue with question 3.1 on page 21. So we have 3p plus q squared if 9p squared plus q squared is equal to 12 and pq is equal to negative 3. So the first thing I did is I squared this. So I multiplied 3p into 3p plus q and q into 3p plus q, right? So I got the answer to be 9p squared plus 3pq plus 3pq plus q squared, right? So 9p squared and q squared doesn't have like terms, but 3pq and 3pq can be added together to give us 6pq. I just rearranged the whole expression so that it reads algebraically correct. Right, so now we have this 9p squared plus q, which is 12, right? They gave us the value first. And then the 6 is this 6 here, and I replaced PQ with negative 3. So 12 plus negative 18 gives us 12 minus 18, and our answer there is negative 6. We continue on the next board. So now we need to solve for x. So 2.1.1 says px plus qx is equal to 8. We combine like terms, so we put p and q together. X equals a outside of it. And when we solve all of this, it is a over pq. So x, the value of x is a over pq. We are still solving for x, and it's 2.1.2, which says x squared minus 5x plus 2 equals 0. And we're going to use our quadratic formula to solve this problem here. So x is equal to negative b plus minus b squared minus 4ac under the radical sign over 2a. So our value for a is 2, b is negative 5, and c is 2. Started substituting in the value, so negative 5 plus minus negative 5 squared minus 4 multiplied by 2 multiplied by 2 all over 2 multiplied by 2. Solving all of that, we get 25 minus 16 over 4. Right, so 25 minus 16 leaves us with the square root of 9 over 4. Then x is equal to 5 plus 3 over 4, or x is equal to 5 minus 3 over 4. 5 plus 3 is 8, and then over 4, if we divide 8 by 4, we get an answer of x being 2, or x is 5 minus 3 over 4. 5 minus 3 is 2 over 4, and when we simplify that fraction 2 over 4, we get half. So the value of x is either 2 or 4. Then 2.1.3 says half raised to the power of 3x plus 1 is equal to 32. In order for this to make sense, we first rewrite 32 as 5 to the power, 2 to the power of 5. So now that we've rewritten 32 as 2 raised to the power of 5, we take half in the brackets, 3x plus 1 equals 2 over 5. But what happens here that the half goes away is we multiplied this with 2 over 1 so that we could get rid of the fraction part of it, and then those two cancel each other out. So we are only left with the exponential part of it. So 3x plus 1 is equal to negative 5. 3x is equal to negative 5 minus 1. This one we take over the equation sign. It then becomes a negative. In order for us to isolate the variable on the one side, we now divide both sides by 3. That leaves only x. When these 3 cancel each other out, then it's a negative 6, so a negative divided by a positive gives us a negative, and 6 divided by 3 is equal to 2. We're moving on. Then finally 2.2 says negative 11 is smaller or equal to 3m minus 8, which is smaller than 4, right? So we add 8 to all parts. So negative 11 plus 8 is smaller or equal to 3m plus 8 minus 8, which is smaller than 4 plus 8. So we have here negative 11 plus 8 gives us a negative 3. Then we have our sign. 3m is left on its own because a positive 8 and a negative 8 cancel each other out, and 4 plus 8 is 12. Then in order for us to isolate this variable, we now divide all 3 terms by 3. So negative 3 divided by 3 gives us a negative 1. We keep our sign as is, Then this 3 and then there 3 cancels each other out, and 12 divided by 3 gives us 4. They wanted us to give the 5 integers that would be applicable here or in the range. So it's negative 1, 0, 1, 2, and 3, because 3 is smaller than 4. That's why we stopped there.